Today I'm going to be showing you about the Hardy-Weinberg equation. So the equation is p squared plus 2pq plus q squared equals 1. So p squared equals homozygous dominant, q squared equals homozygous recessive, and 2pq equals heterozygous, p equals frequency of dominant allele, q equals frequency of recessive allele. P plus q equals 1. Okay, so here's an example. 25% of dogs in the US have cancer. Recessive. Dogs with cancer are recessive for the cancer disease. Alright, so these are the type of questions they'd ask you. So number 1, what percentage of dogs have cancer in the US? Number 2, what is the frequency of the dominant and recessive allele? And number 3, what percentage of the population are heterozygous for the trait? Okay, so for step 1, you want to find q squared, because q squared is a homozygous recessive, and as it tells us right here, 25% of dogs in the US have cancer, which is recessive, so that is 25%. But you always want to put it in decimal format, so it is 0.25 that q squared equals. So you want to square root this. Q equals 0.5. And number 1, what percentage of dogs have cancer in the US? So we have it right here and right here. So we'll just put the percentage, 25%. Number 2, what is the frequency of the dominant and recessive allele? So you want to find Q and P for this one. So since Q equals 0.5, you want to subtract that by 1. And that equals 0.5 as well. So P equals 0.5. So it's going to be 0.5 and 0.5. Number 3, what percentage of the population are heterozygous for the trait? So on here you want to use the equation of 2pq, and then you just plug in q and p. So 2 times 0.5 times 0.5. Alright, so 2 times that is going to be 0.10 times 0.5 is going to equal 0.50, and that is the answer. But as for the percentage, so you just want to move that over here, 50%. Alright, so that is the Hardy-Weinberg equation for this example, and thanks.